Hello, Miss Winelander here, and we're going to go through the third Need to Know video from Unit 2 in Algebra 1A. That's talking about real numbers and the number line. So, here's the objective. This comes from your Connexus lesson. Remember that this video that you're watching right now replaces that first part of your Connexus lesson. This is your instruction. You do not also have to do the Connexus instruction. So your objectives today are to classify, graph, and compare real numbers, and to find and estimate square roots. So how will you know when you've accomplished those objectives? Well, there's a few success criteria here that hopefully at the end of the video you can check off, or you can find resources to get to so you can check it off before your unit test. So there, I can identify and define irrational numbers. I can identify and define rational numbers, natural numbers, whole numbers, and integer numbers. So what are all of those? I can estimate the value of a square root, and I can simplify the square root of a perfect square. I can compare two or more numbers using an inequality symbol. I can order two or more numbers from least to greatest, and I can place two or more numbers on a number line. So we've got a lot of keywords, which makes sense because we had a lot of success criteria here. A lot of these you've probably heard before, but maybe you're not super familiar with yet. So let's go through a few of these kind of as we need them. So square root. Probably heard of square root before. If you remember, the square root of a number is kind of like the inverse operation of squaring something. So this one says if a number a is the square root of a number b, if a squared equals b. So that a is that square root because if you would square it, you would get to that original number b. You're probably more comfortable going through this with specific numbers, maybe rather than variables, but it's good to think of it in both terms. So this example I give you is that since 7 squared, or 7 times 7 is 49, 7 is the square root of 49. We used one in our last video where we did 5 squared to get to 25. That would mean 5 is the square root of 25. So some key vocabulary that goes along with talking about this, we're all talking and saying it in similar manners, is radical and radicand. So the radical symbols, that's actually that root there, that square root. Later on in other math classes, you'll get to cube roots. You could take a 7th root. If it doesn't have a number kind of right in that little spot there right above what looks like the beginnings of a check mark, then you assume it's a square root. That means that it's the inverse of squaring something. So something times itself. If you ever see cube root, that would mean that it would be cubing something. So the radical symbol is that giant check mark. The radicand is what's under it. All right, so let's start practicing some here. So our first problem is simplifying square root expressions. So what is the simplified form of each expression? Remember, simplifying means we're not going to have that equal sign. Instead, we're going to write it in the simplest form, the easiest form, kind of smallest form frequently. So for A, we have the square root of 81. So the radical is that square root symbol. The radicand is 81. So what is the square root of 81? Well, it's 9, because 9 squared equals 81. Now, if you don't have some of your perfect squares memorized, that's okay. You can try these out on your calculator. Make sure that you use that square root symbol here. I can show you that using the calculator that comes with your computer. Make sure that you are in scientific mode for most of our calculations, even though you'll see it on the standard as well. So it's that looks like a little check mark here. So if you want to find the square root of 81, if you are in scientific, it's just a little bit further to the left there, but same idea, looks like a little check mark. For part B, we're now going to find the square root of 9/16. So there's a couple ways you can think about doing this. You can think, well, what is a number that when it's multiplied by itself, when it's squared, you get to 9/16? Or you can kind of break apart both the top and the bottom, the numerator and the denominator, and think of them each separately. So the square root of 9 is 3, because 3 times 3 is 9. Square root of 16 is 4. 4 times 4 is 16. So your final answer is 3/4. Make sure, since it's given in a fraction, you keep it as a fraction. So if you use your calculator, it can help you either check your answer or give you an idea of where to start, but don't write down the decimal approximation. So if you do 9 divided by 16 and then take the square root, you get 0.75. We know that 0.75 is 3/4. It's kind of like 3/4. But you're not going to write down 0.75. You're going to write down 3/4. So now that we've gone through how to simplify some square root expressions, pause the video and try this problem on your own. So you got 4 parts to it, A, B, C, and D, to make sure you're working your brain out and getting some good practice there. Keep good track of where you're writing this down. I recommend putting it on the note sheet that's in the attachment, either on the message board or the modification notes. If you use another piece of paper, that's fine too. Just keep it somewhere safe, because you're going to turn in all these practice problems from all the videos in Unit 2 at the end of the unit for your sample work assignment. Well, welcome back. We're going to talk about some more vocabulary. So we saw all those key terms at the beginning. We only defined 2 of them so far. We have quite a few more here. So we're going to look through. The first one they define is set. So set is a well-defined collection of objects. So sometimes you can have sets that say natural numbers, like we'll talk about here, or you could have sets of even numbers. You could have collectibles. It could be sets of colored pencils. It could be sets of fancy coins. Whatever. It's a well-defined collection of objects, so you know exactly what's in that set. Each object in that is called an element of that set. A subset, so you have that set that's a larger group. The subset is a set that contains elements from the given set, and it's kind of like within it. So you could say, well, like, I have a set of all numbers, and I have a subset of even numbers. Because it's within all numbers, but it's even more specific. They define these because you'll see these terms. You also have this document available to you to help you out with subsets of real numbers. So that's why they want you to know, when we say subsets of real numbers, what does that mean? So we're going to talk about some of the main ones. So first of all, a rational number is any number you can write in the form A divided by B, where A and B are integers that are not 0. That's true. How I think of it is it's a number that makes a little bit more sense. It follows a pattern. As long as it's a consistent pattern, then you know what it is. So you either have a terminating decimal, so it ends somewhere. So our last example, 0.75, that's a rational number. Or it could be a repeating decimal. And that's, like 1/3, 0.33333333333333. That's also a rational number. So once you have an idea of rational numbers, that's a subset of real numbers, but it's a pretty large subset. And there's subsets within rational numbers. So one that's mentioned is natural numbers. So I've heard that rephrased as counting numbers before. So it's 1, 2, 3, 4, 5, continuing on and on. Whole numbers are all natural numbers, and then it also includes 0. So natural numbers do not include 0, whole numbers do. Sometimes when people just talk about different numbers, sometimes they say whole numbers and they mean 0. They might even mean integers with negative values. But from a mathematical standpoint, these are the definitions of these. So now you know how to use them correctly when you're talking. Integers are natural numbers and whole numbers, and negative natural numbers. So that would be, negative 17, 0, 1, 1 million. Those are, again, subsets of rational numbers. There's also numbers that are irrational. The most famous of those is pi. So you can watch videos of someone listing off all the values of pi, and you'll notice that there's not a clear pattern. So remember, it's not a rational number. You can't write it as a fraction. The decimal doesn't truncate or end. It doesn't repeat in a rational way. Another example your book gives you is 0.10100100001 and on and on and on. If you need, there is this in the help section of the message board and on the additional sections there. It's a clip art that can kind of help you organize these. So if you look there, you can see that real numbers involve everything in that rectangle. And then you have rational numbers in that blue oval, irrational in that gray, and then within rational you have your integers, your whole numbers, your natural numbers. So getting smaller and smaller, more and more and more specific. Your book phrases it a different way. They set it up in this way with those kind of green getting smaller and smaller, more and more specific, more and more in-depth subsets. So for problem 3, we're going to classify real numbers. So to what subsets of the real numbers does each number belong? So for 15 here, so let's start kind of the widest part, the least specific as far as real numbers go. Is it rational or irrational? Well, it is rational. It truncates if you're talking about a decimal, 15.0 if you really needed to think of that for 15. So it is rational. Within that is your integers. So remember, that's negative, 0, and positive numbers, positive natural numbers. So this is positive, so it counts as far as a integer. Is it a whole number? Is it either positive or 0? Yep, it's positive, so it's also a whole number. And then the most specific is those natural numbers, your counting numbers, and it's 15. So yes, it is a natural number. Now let's look at B, negative 1.4583. So it is a real number. Is it rational or irrational? Well, it is rational because it does stop after those 4 decimal places. It doesn't continue on afterwards in any manner, either forever or in a non-repeating manner. It truncates, terminates. So it's rational. The next subset that's inside rational numbers is your integers. That's your negative, your whole, and your natural numbers, and your negative natural numbers. Well, those do not involve decimals or fractions, so it is not an integer. So the only real number subset it belongs to is rational. For C, we have the square root of 57. So let's figure out kind of an approximation for that. So square root of 57, 7.54983444352. So I notice it continues on and on and on. It does not terminate or truncate. It does not repeat. So it is irrational. You could not represent it as a fraction. So we reviewed these. You can use this in your knowledge and your note sheet to pause the video and try question 2. So again, remember, write this in a safe spot so you can keep track of it and turn it in at the end of the unit. So now that you pause the video and you're back with us, let's go on to the next question here. We're going to graph and order real numbers. This is a multiple choice question that we're going to go through. What is the order of the square root of 4, 0.4 or 4/10, negative 2/3, square root of 2, and negative 1.5 from least to greatest? So there are many ways that people can approach this. I like to kind of draw a number line and start writing down approximations of some of these values. Some of these you might be able to place on there pretty quickly. So 0.4, that's in between 0 and 1, almost halfway, but not quite. So it's 0.4. Negative 1.5, so it's going in the negative direction, 1.5 more. So negative 1.5. Right, negative 2/3, so it's in the negative direction. Not a whole part, it's 2/3 of the way through, so negative 2/3. Now we're left with our radicals, our square roots here. So we can find the approximation of those. So the square root of 4, that is a perfect square, because 2 times 2 is 4. So square root of 4 is 2. 1, 2. The square root of 2. It's not a perfect square. There's not a natural number that when you square it, you can get to 2. So you can approximate it by thinking about what is it in between. Well, it's in between 0 and the perfect square for 4, which is 2. So it's in between there. You can also get a decimal approximation on your calculator. Okay, 1.4142, la 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 la. So it's right around. It's right around here. So that'd be the square root of 2. Since we put them on the number line, it already arranges it from least to greatest. So now we just have to write them in their appropriate location. All right. Now 2 is also the square root of 4. So you might see it written either way. Let's look at, does it fit with option A, B, C, or D? It looks like C. So now that we reviewed how to graph an order, you're going to pause the video, try one on your own. Again, this helps you to see that I understand this question. It also is going to be turned in for their sample work assignment at the end of the unit. Now that you're back, let's just review this video to see, are you confident in checking off all the success criteria so you have achieved the objectives of this video? So can you identify and define irrational numbers, rational numbers, natural numbers, whole numbers, integer numbers, all those in that graphic organizer we saw? Can you estimate the value of a square root? Can you simplify the square root of perfect squares? Can you compare 2 or more numbers using an inequality symbol, ordering 2 or more numbers from least to greatest, and placing 2 or more numbers on a number line? So we kind of had our 3 groups of success criteria. That's why we focus on 3 main problems from today's video. Your next step is your exit ticket. You're going to go to masteryconnect.com/bubblesheet. If there is a test ID here, you will write that in, type that in. Type in your student ID found at the top of your gradebook and answer any of those questions. Then you've completed the modified plan for the 3rd lesson in Unit 2 for algebra. So now you can go to the very end of your lesson to complete that assessment. If you have any questions, let us know. Otherwise, I'll see you in next lesson.